I'm Stephen Foskett, and this is Tech Field Day. The video you're about to see brings together a panel of a dozen delegates from around the world who focus on enterprise technology to talk and learn about new technology products from companies like DriveScale. If you'd like to learn more about this, you can go to techfieldday.com. And if you like this video, you can see a lot more at youtube.com/techfieldday.
My name is Satya Nishtala. I'm the CTO and one of the founders. And I'm actually the only hardware guy in the company. So I get to talk to you guys about the hardware that we have. Essentially, this is the box. Tom has shown you the back of the box. That's where all the interesting things happen. We have the box has got 4 of our adapters. Each adapter has got 2 10 gig interfaces and 2 SAS interfaces. So with 4 of these adapters, you get 80 gig worth of throughput through this particular box. And the chassis itself is a fully redundant kind of a chassis. The power supplies are redundant, and everything is hot pluggable. Okay, so if there is any failure, you can just pull it out and put in a new one. Everything is just fine. And each of these adapters has got an autoband management interface. And so there are up to 4 management interfaces out of this adapter. And the box can be managed out of just one of them. Okay? So, and in the front of the box, we have place for 10 NVMe drives. Okay? So this is a functionality that we don't enable at this time, but we have a capability to export the NVMe drives as well into the pool of drives that are available. Okay. That is something that we're going to do later on. But this is something, and also just like everything else in the box, the NVMe drives here are also dual ported. Okay, any controller can die, and then we still have access to the drives.
Sorry, what are the drives on that one being used for specifically, or when that comes?
Just like you are exporting a hard drive from a JBOD to a server, you can export a part of an NVMe drive to a server.
Okay, right.
Okay, you can carve out an NVMe drive to a server. The thing is, it does not make sense to carve out a hard drive, because Hadoop applications are very intense at doing a large number of sequential accesses. Okay, and partitioning a drive messes it up big time. Whereas it's a fair game to do that for SSDs. Okay, it makes sense to do that. In fact, today, these drives are available at 2 terabytes each. Okay, at 2 to 6 terabytes. So you can have a fairly decent amount of SSD that can be exported from here. That is something that we are going to do later. And also, this is the NVMe drives that will be exported from here will not have the absolute maximum performance that NVMe will be able to give you. We'll talk about that in a little more detail later.
Is there any intention for using that as any kind of caching tier as well?
Yeah, that's the idea.
Right.
Okay, that's the idea.
So you said you can carve up portions of the drive, not the entire drive, right?
Yeah.
Okay.
Because for SSD, it is viable to do that.
Okay.
For a hard drive, it's not viable.
Right.
So what is their use today?
Nothing.
Nothing? Okay.
It's a future.
Gotcha.
So they're just there, they're not populated.
They're not populated. But the entire box is designed for take advantage
More
of
than
that.
6K box if it was populated.
What's that?
It'd be more than 6K box.
Yeah, in
Short
fact,
version is you have plans.
pardon?
The short version is you have plans.
Yeah, yeah. I mean, as you said, the use case is caching, write caching, edge-based caching. But essentially, fundamentally, what it is that HDFS also has a notion of tiered storage, and then we can assign SSDs as well into that storage.
Yeah, another key application is boot drives, so people can go to truly diskless servers. Then that would enable repurposing the servers in seconds instead of minutes.
So once the SSD is live, it'll just be a matter of existing customers call you up and order the drive, pop it in, and
That's the idea.
So just to check as well, just to be absolutely sure then, in terms of the caching piece, is that going to be done by Hadoop, or are you also intending to add in your own flavor of that as well?
Yeah, we will add in our own flavor so that it's transparent. You know, kind of like a RAID controller will do caching for you.
Yep. Okay, cool.
Okay, so inside of the chassis, what we have, as I said, there are 4 controllers. I'm showing 2 of them. And what it shows is the 2 controllers and the dual power supplies. And this shows how the controllers get attached to the slots in the front. So each of the NVMe drive slots are dual ported, connecting to the controllers.
But when you buy this, you're required to have 4 controllers with the.
We always sell it with 4 controllers.
Okay.
Okay, we don't intend to sell partial
Sure.
adapters. And this is what's inside of that. And what we have, the heart of that is a network processor. The reason why we chose a network processor is this is an extremely efficient data mover engine. Okay, the network processor itself comes with 2 10 gig interfaces and PCI Express, and when it is moving the full 20 gig bandwidth out of it, it consumes just 11 watts. Okay, so the entire adapter is a fairly low power data mover. So from the network adapter, it has PCI Express interfaces that go to a PCI Express switch to the NVMe slots in front, and also to a SAS controller that lets us get to a JBOD. Okay, and we also have a chassis management network in each adapter card that they are all connected together.
You want to pass it around?
These are all off-the-shelf components that you're
Yes.
bolting together?
Yes.
Are you doing any kind of like ASIC-related stuff, or any intention of doing like
There is-
FPGA-related stuff later?
No. What I have here, okay, the network processor is from Broadcom. Okay, that's not a surprise, and the SAS controller is from LSI, and PCI Express, the PLX switch is from the PCI Express switch is from PLX. Okay.
So it's an all-Avago board.
Actually, initially when we started, there were 3 different companies. Now it's one company. Okay. So 4 of these guys get you slide them into this chassis. So this is the deployment model, as we talked about. Essentially, what you have is a bunch of servers with NICs on them that you connect to the top of rack switches. And then from the top of rack switch, you go to the DriveScale adapters. In the DriveScale adapters, you connect to the JBODs in a redundant fashion, so that there is no single point of failure. Okay? And in this model, what you see here is that all of the stuff that I'm showing in blue and orange is something that you could buy from anywhere. Okay, we don't sell any other stuff. We just sell the DriveScale adapters and the management system. Okay, as I said, the servers can be any type. Okay, as long as the interface point is 10 gigabit Ethernet. That's where we are. Okay, actually, in our market, as I said before, we are going into a market where people buy hundreds of servers. We don't want to get into the supply chain. We let them buy whatever they want to buy. Okay. So in a typical rack configuration, this is what you would have. You have a JBOD and an adapter with it. So you get a stack of those, and you get a stack of servers. Okay, what I'm showing here are dense servers. There are actually 4 servers in a 2U box. These are standard servers from Dell that I'm showing here. So you could, and also the 2 top of rack switches Again, what I'm showing here are you could buy switches from any of the vendors that we are talking about. Now, in fact, we tested with Cisco, Arista, Dell, and Cisco, Arista, and Dell. And then you could buy any management switch. And we have tested with a bunch of rack servers as well. In fact, a bunch of servers that we have are from Foxconn and Dell and Supermicro and Cisco. Okay, the thing that is interesting in this model is that you are able to populate a whole number of servers over here because there are no disks in them. What I show here is a configuration which actually shows you the value of deployment value of DriveScale. It provides you the density and flexibility. This is a standard configuration that you would have with 2U servers. What you get are 18 servers and 216 drives, with each server having 12 drives. That's the fixed configuration that you are going to get. Okay. And that is something that you get to choose at the time you buy all of these servers. In a DriveScale model, what you would have is if you chose that 4 servers per 2U box, you get 28 servers and 300 drives, and on average, 10.7 drives per server. So so here we define an average. Here it's a fixed value, right? And if you use a larger switch, then your pod can actually be 2 racks together, and you have a larger pool to work with. Okay, shows a much bigger configuration.
So cross cabling between racks on every node in that instance in the last one, or are you just connecting it at the top?
Yeah, you just connect it at the top, right? The network cables obviously will go between the 2 racks.
Right? For every node, or just between the switches?
Right.
Well, yeah, in that case, there's only one switch for the 2 racks. Yeah, that's for people who want to use the huge.
The 128 port switch is what you would use. Okay.
What's the typical power configuration you see for like that? If I was doing a single, your kind of middle stack, and how much power would it use?
This I think I had this one. This was about 11.7 kilowatts.
Okay. And what would it be for a typical kind of standard 2U? Did you do that analysis?
Yeah, I did have. I can share that with you. I have a detail of that.
It's less, but people are moving to larger and larger allocations of wattage per rack.
I agree there. I mean, I'm a service provider, so what I try to configure is I look at, how much reduction is this going to provide me? If I'm providing this as a service, and if I start using, the DriveScale configuration, what's my watts per gig go down to? I mean, what's that look like? If it's a dramatic,
actually, those are.
If it's dramatic, it makes sense from a cost respect for me.
The place where it gets dramatic is, on the left side, if you need a certain amount of compute and it only comes in the 2U servers, and you need a certain amount of storage, you're going to be making trade-offs where maybe I only have 20 cores per system. All right. Well, in our system, you can say, hey, let's drive it up to 40 cores per system, and put all the storage externally. So you got a lot more cores per system, which is a lot cheaper per core.
Actually, now that you mentioned service
and cooler.
Yeah. Actually, now that you mentioned service provider, there is another interesting application space for this one, and that is for bare metal service providers. Okay, if you are familiar with companies like SoftLayer, for example, you try to go and provision a server with a SoftLayer. They have about 25 to 30 different SKUs to choose from. Okay, and then you pick your configuration, and about 4 hours later, they will tell you that they have assembled the configuration for you, and that's physically done. Okay, in this model, all you need is one SKU of server and the JBoards, and click, and you're there. Okay, so you don't need different varieties of things to work. Okay, that's a major advantage, and you are pretty much providing the bare metal service much like AWS.
Yeah, that's definitely an interesting thing to think about. I'm not sure how the licensing would be handled, as you still have to worry about the underlying, cores per socket underneath. So 'cause you're basically giving me a virtual abstraction of the cores when you're provisioning something to me.
No, here I'm not provisioning down to a core. I'm provisioning to a server.
Yeah, but if I'm saying I'm going to put this much CPU inside of my configuration, I'm going to have to worry about what that's actually going to tie to the processor underneath, right?
Yeah, you still have granularity
Yeah.
about how big is your server, but
Right.
you don't have to factor in all the storage. And
Sure. Yeah, I mean the storage gets easy, but the server side of it's still a complexity.
Actually, we don't get into the server licensing part of the game because
Yeah,
that's something-
I have to though. That's what I have to worry
right,
about.
right. Because that's the part that really the either the service provider of the software vendors, it is their domain.
Yeah, I get it completely.
Yeah.
Yes.
Okay.
That's my problem. I understand.
Yeah, yeah. In fact, I would be more than happy to go over the power structures with you. Okay. Going forward, right? As Tom talked about before, it is possible with 100 gig, 25, 50, 100 gigabit Ethernet coming along. It's possible to disaggregate very high performance NVMe SSDs as well. The goal here is to be able to provide the same performance as an in-box SSD, high performance SSD, disaggregated. Okay, what are the enabling technologies? It's the 2550 100 Ethernet. We think that this is going to have big traction next year. Okay, all the components are available already from Broadcom, Intel, QLogic, and Mellanox. And the switches are already here. The 64 and 128 port switches are already here. And there are high performance network processors that are available from the market already. The silicon is out. They are from Broadcom, Cavium, Annapurna, CNX Labs, and Kazan. These are the different people who are able to provide the bridge, if you will, from Ethernet to the PCI Express NVMe drives. Okay, and the important thing is that with this technology, you are able to do that with a latency overhead of less than 10 microseconds. And if you look at a high performance SSD, native latency is about 100 microseconds. So essentially, you are adding 10% overhead on top of that, and that's it. Okay, you are able to get the advantage of that is that in most cases, when you install an SSD inside of a server, you always over provision. Over provisioning of SSD is very expensive. Okay, and also when that server dies, you lost your SSD. Whereas here, you just reallocate it to another server and you're ready to go. And essentially, what we are saying is that we will enable this ecosystem into our product line, and then we will be able to manage NVMe SSDs exactly the same way we manage hard drives. Okay, that's what I have.
And is the intention that it would be a minimum requirement of 25 gig networking, or could you support it on 10 because somebody just wants low latency, they don't care about throughput?
Yeah, exactly. So, as Tom was saying, at a networking level, we stay with Ethernet. So